Video will cover how to factor quadratic functions with a leading coefficient of 1 or with a greatest common factor. So factoring means taking quadratic equations from general form to factor form. So going from this to so let's look at an example. I've got the function x squared minus 4x equals negative 3, and I want to convert this to be in factored form. A reason why you might want to do that is to make it easier to find the x-intercepts of the function. So the first step is that the function needs to be equal to 0 on one side. Right now I have the right side equal to negative 3. So I want to think about what can I do to that side to make it be 0 instead. Well, since I have negative 3, if I add 3 to that side, negative 3 plus 3 will give me 0. So I'm going to add 3 to the right side. And whatever I do to one side of the equation, I have to do to both sides of the equation. So I will also add 3 to the left side. So I'm still going to have my x squared, and I'm still going to have negative 4x. I cannot combine the 3 with the negative 4x in any way because they're not like terms. This one has an x, this one doesn't. So they're not like terms. I can't combine them. I'm just going to write a plus 3 at the end here. And on the right side, like we said, negative 3 plus 3 is 0. Once I have one side of the equation equal to 0, then I'm ready to begin the factoring process. This is because, again, we're looking for the x-intercepts. The x-intercepts are when the y value of a function is 0, when the function output is equal to 0. So my next step is to look for two numbers that multiply to the c value of the function and add to the b value. So again, those b and c come from our sort of template for general form. C is the number all the way at the end by itself, the constant, and b is the number that's next to the x. So in this equation, my c is 3 and my b is negative 4. So I need to find two numbers that multiply to 3 and add to negative 4. Well, I don't have a ton of choices for what multiplies to 3. Two numbers that multiply to 3 are 1 and 3. Let's see if those add up to negative 4. Let's see, I'm going to find the sum. 1 plus 3 is 4. So no, that's not what I wanted. I wanted a negative 4. Well, another two numbers that multiply to 3 are negative 1 and negative 3. Negative 1 times negative 3 would also give me 3. Let's see what those numbers add up to. Negative 1 plus negative 3 is negative 4. There we go. That's what I wanted. So once we found our magic numbers that multiply to c and add to b, we're going to put those numbers in parentheses with some x's. So x minus 1 times x minus 3, and that is still equal to 0. So these are two ways of writing the exact same thing. These are totally equivalent, just written in different ways. You can see that if we were to multiply this back out, distribute or FOIL it, we would get x times x, which is x squared, x times negative 3, which is negative 3x, negative 1 times x, which is negative 1x, and negative 1 times negative 3, which is positive 3. Then if I combined like terms, I would get x squared, negative 3x minus another x is negative 4x, and plus 3 at the end. So I would wind up back where I started from here. This is to show you that writing it in parentheses like this is an equivalent function to what we started with. So once I've got my magic numbers in parentheses, I'm going to use something called the zero product property. What that means is that I've got this set of parentheses times this set of parentheses equaling to 0. I've got two items being multiplied, and I'm winding up at 0. Well, the only way that that can happen is if one of those items is 0 itself. Right? Think about how we can multiply to 0. 4 times 0, 0 times 3, 0 times 100, 0 times 1,000,000 would all give us 0. So the only way we can multiply two things and wind up at 0 is if one of those things is a 0. So this is going to lead me to two equations. Either x minus 1 could be 0, or x minus 3 could be 0, or both. If this was 0 times a number, I would get 0. If this was a number times 0, I would get 0. Or if this was 0 times 0, I would get 0. So now we've got two small equations that we need to solve. Let's start with x minus 1 equals 0. Here, 1 is being subtracted from x. I can undo that and get the x alone if I add 1. So I'm still going to have an x. Negative 1 plus 1 is 0, so I don't need to write that. And on the right side, 0 plus 1 is 1. With this equation, 3 is being subtracted from x. I can undo that by adding 3 to both sides. I'm still going to have x. Negative 3 plus 3 is 0. I don't need to write it. And 0 plus 3 is 3. So now I've got my two answers. I know that the numbers that make this original equation true are 1 and 3 for x. And I know that the x-intercepts of the function x squared minus 4x plus 3 are 1 and 3. You can see if I was to plug these answers back into any of these equations, they would make them true. So for example, if I plug in 1 to this equation, I'm going to get 1 minus 1 times 1 minus 3 equals 0. 1 minus 1 is 0. 1 minus 3 is negative 2. 0 times negative 2 is 0. So yes, that makes the equation true. That would work with 3 as well, and you could plug them into any of these forms and the equations would be true. Sometimes I do have an additional step to do at the beginning of my factoring. You'll notice that for this equation, a in the front is not 1. It has to be 1 in order for us to do our factoring. But I do notice that all of these numbers, a, b, and c, are divisible by 3. They all have a greatest common factor of 3. So I'm going to start by factoring out that 3. I'm going to start by sort of reverse distributing, taking out that 3 from everything. So the 3 will get written in front. And what goes in the parentheses is what happens when I divide all of these by 3. So 3x squared divided by 3. The 3's would cancel out and I would just get x squared. 21x divided by 3. And divided by 3 is 7, so this is 7x. And then 36 divided by 3 is 12, so plus 12 equals 0. So you can see if I was to redistribute this, I would get 3x squared plus 21x plus 36. So in essence, I have undistributed the 3. Now we're ready to do our normal factoring. So I want to look for numbers that multiply to 12 and add to 7. Those numbers are 3 and 4. 3 times 4 is 12. 3 plus 4 is 7. So I'm going to write this as 3 times x plus 4 times x plus 3 equals 0. Now I'm going to set up my two equations. You can just ignore this number in the front. So either x plus 4 equals 0 or x plus 3 equals 0. I'm going to subtract 4 from both sides. X could be equal to negative 4. And here I'm going to subtract 3 from both sides. X could be equal to negative 3. So sometimes we have one additional step, which is to divide each term by the greatest common factor, by the biggest number that goes into a, b, and c evenly. So that is how we can factor quadratics to find their x-intercepts.